Okay, so the first part of the session today, we're going to look at chapter 4 and 5. So we're starting off with probability. So the basics around probability, and then we will go into discrete probability. So discrete probability will look at things like discrete. It will look at binomial and Poisson distribution, and then in this we'll take a few minutes break, and then we'll start with study unit 6 and 7, and let's just see how far we then get with the normal distributions. Okay, so on probability, again, just a few basics that is in the pack so that you guys have it with you if you still need some of um, the definitions and those kind of things. So what I've done is just created a few slides around that again, so that if there is anything in the exam, you are allowed to use this summary packs. So mutually exclusive events, very important that we know that. The important thing about mutually exclusive is that you see that this and is equal to 0. So that is when things are mutually exclusive. Basically means that there is no overlap or overlay. When it's not mutually exclusive, you will see that there is a bit that can be linked to the probability of A and a bit linked to the probability of B. Okay, so that basically is the big difference between mutually exclusive and not. So mutually exclusive events, the AND is always equal to 0. And that is important because in some questions, they will tell you that A and B is mutually exclusive, and they will ask you to work something out. In some other instances, they might talk about the events that are independent. So when events are independent, the important thing to get that and is to basically say the probability of the first event, so if it is A, times the probability of a second event. Okay, so that is how we will get the and when it is independent. So that basically is two very important things to remember, especially when we get to some questions, because sometimes they tell us A and B is mutually exclusive, or sometimes they tell us A and B is independent. So in those instances, they don't need to give us the and, because you will be able to work it out because of the rules around mutually exclusivity and the independence. Then we also have some conditioning rules. So and how we normally read this is probability of A given B. So also when we get to questions, they might sometimes say, what is the probability of somebody having blue eyes given that that person is also have blonde hair or something like that. So a lot of times they will tell you in words, it's the event of one given the event of another one. or if it is when written as a formula, um, it will be, and how we read it is probability of A given probability of B. And how I normally read this, and to make it a bit easier for myself, is when to say, okay, but how do we read this? We can say it's the probability of the A and the B, because that's the two at the top, and then it is divided by the probability of the one that's standing last. Okay, so that is how I would read it, and then it is easy to do. So if you had that where it said probability of blue eyes given that the person is blonde, that's just a made up one. So let's just, then it would have been the probability that the person have blue eyes and the person is blonde divided by the probability that the person is blonde. Okay, so that will nearly be, when we look at conditional, probability of A given probability of B is the probability of A and B. So basically the AND of the two divided by the probability of the last one. Sometimes, but I don't think I've seen this too much, but if I use that, it means and, so it is basically what is included in both. So I always see that as nearly what is from A and included in B. So I see it nearly as to remember what is in the and. Sometimes, and I don't think I have it, but sometimes they do the union thing as well, and that just means A or B. Okay, but that is just in some textbooks, but I don't think I've seen it in any of the exam papers. Then just some other basic rules that sometimes they put into questions. So the events must always be between 0 and 1. So they might sometimes throw that in as a theoretical question. What you sometimes also get is that they talk about the complement rule. So basically, the complement is if a probability of A and you want to get the complement, it's the probability of 1 minus the probability of A. So basically, you're looking for that piece that will make it 1. Other things that they might sometimes ask is how to work out the probability if you have certain number of, and let's say how many aces there are in a deck of cards. We know that there are 4 aces, and we know there's 52 cards, so that will nearly be how we will work out that probability. So let's see what else is important from a probability point of view. I think those are the most important things that you guys need to know. Interesting how this now actually went over a few. Ooh, let me just save before something bombs out on my side. Not worried that that will. Okay. So then, as I said, we're also looking at discrete probabilities. I see that now copied everywhere, so something is not nice now, but I just quickly want to see that now. See why this is not doing that. I don't want. Okay, let me quickly just to get back into this. That was weird. Okay, cool. Let's now just see that everything is working. Okay, perfect. Okay, so then we go into the discrete probabilities. So study unit 5. And discrete, basically, you will, as we did in study unit 1, discrete is numbers 0, 1, 2, 3, 4, 5. There's nothing in between. So basically what will happen with discrete is you will be told in a diagram or a table or something, the probability of 0 is 0,1, probability of 1 is this, and you will get a discrete table that you need to work with. And out of that discrete table, they might ask you a few questions on getting probabilities between certain discrete numbers, or they can ask you to work out the mean, and the mean we work out with a specific formula, and sometimes they might ask you to work out the variance, but what I have realized is that most of the times you can work out all the rest and then know if the answer of the variance is correct or not. But you don't always need to go into the detail to work out the variance. But if you get all the other questions worked out, you know what your decision about the variance will be. Okay, so that's on discrete. Then another one of those probabilities in study unit 5 is binomial. The binomial distribution, we will get information so that you will be able to use your tables. So very important for binomial distribution. Most of the time we will use the table. Sometimes, and I think I've got a question like that in, sometimes they ask a question around the formula, where they give you information to write out the formula. They will never ask you to work out the probability using the formula. Because if you need to work out the probability of x smaller than 2 or something like that, you need to do a few of these sums. So they will never ask you to work out the probability, but they might tell you certain things around the binomial probability, and as the one that I will show, I think all binomial, all from the Poisson distribution. I will show you guys just how they can ask that in a question where parts of it has been completed for you. Okay, then other two important things is they might again ask you to work out the mean. The mean is just n times the pi, so whatever they say that is, and the variance is also for binomial a very easy calculation. So in this instance, you don't need to look at all the data. You'd basically look at your n and your pi that they will give you. Then the last one of these are Poisson distribution. The big difference between binomial and Poisson is that with Poisson there is this extra thing that they bring in. So time, distance, area, volume. So there's this extra dimension that they bring into the question. So if I don't tell you it's a Poisson distribution, just look out for these extra words. But again, we will go through one or two of the questions and see how we can identify all of these things for you in a question as well. Poisson, again, we'll use the Poisson table, but if there is anything that we need to do with the formula, again, they will not ask us to work out what's the probability where x is smaller than 3, because then again, you need to do a few questions or few calculations. But important again, if they give you the lambda and maybe x, that you can write that in the formula way. Then other thing about the Poisson that's different to any other distribution is that the mean and the variance is exactly the same. Okay, so, and they are then also the same as that lambda. So variance, mean, exactly the same. Okay, so let's get into a few questions. So this is looking at study unit 4 of probability, and then study unit 5. So it's a mixed bag of that. And what is nearly important in this instance is that they can, as I shared this for you guys to have as information for nearly a theoretical question, they can throw that into something that is theoretical and a bit that you need to be able to work it out. So let's look at the things that they ask, and which one of the following statements is incorrect. That automatically again be aware of that. Regards to experiments, counting rules, and assigning probabilities. So nearly things that you need to remember here is what is an experiment. The counting rules includes permutations, combinations, those kind of things. So let's see, an experiment with 3 steps and 4 outcomes. Possible for each step has 64 experimental outcomes. Okay, so that is our first question that we are looking at. So this for me is again where you guys might need to do some calculation. So they tell us there's 3 steps, there's 4 possible outcomes. So for the first one is basically 4 times 4 times 4. So there's the 4 outcomes. There's the 1, 2, 3 steps, and that will give you what you need to do. Another way of looking at it is to say, okay, so then if you want to now do that, that one will have 4 outcomes. That one will have 4 outcomes. That one will have 4, 4, 4. So you can actually design that tree for you and count it. There's 4 outcomes. There's 4. So the easiest is to say 4 times 4 times 4. But you can nearly draw something like that for you roughly and see. But just remember, all of them have 4. So it really becomes small, or you need to just start much bigger than I have. And then if you then get to the end and you add all of those, you will actually get to 64. So try it on a 2 by 2 by 2 or something like that, and see if 2 by 2 by 2 gets you 8, or 3 by 3 by 3 gets you 27. It's a smaller one to just test instead of the 4 by 4 by 4. Okay, so let's just quickly do the 2 by 2 by 2, so that you guys can just see it, because that for me is also sometimes just nice to do that. So 2 by 2, so there's my first 2 by 2, then there's my second 2 by 2, and then each of them will have another 2 by 2. And so that you can use that tree. So 2 by 2 by 2 must give us 8. If you look at it, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that is just a visual of that 2 by 2 by 2. So the bigger it becomes, the more space you need, but this is nearly just a visual representation of how it will also look. Okay, so if I talk sometimes about tree diagrams or things like that, this is actually what how we do it, but you guys don't need to do that. Okay, let's look at the next one. The number of permutations of 4 items that can be selected from a group of 8. And they tell us permutations. So I think the formula looks something like this. Ooh, where's my calculator? Okay, my calculator is in another room. So let me see what I'm going to use quickly is Excel. But on all your calculators, there will be this permutation formula. Just quickly want to, so let's see, that was, the numbers was 4 and 8. Was 4. I think there's a permutation function. So the number is the total number of objects. They told us that is 8. So that's the n. The chosen number is basically how many items we've selected. That is 4. So the permutation should be 1684. Here it is 70, so that one is the incorrect one. Okay, but on your calculators, there is also the function of NPR, like there is, and let's see if there's a combination. So there's also the function of NCR. So let's quickly see here. They talked about N is 7, R is 5. So N7C5. So let's quickly get to this and work out. So your N was 7. Your R is 5. Let's work out the combination. I will share the sheet with you guys as well. I know you 1510 is not allowed to use it. 1610 is allowed to use let's just quickly see. 1610 is allowed to use a clean sheet, but again, I've cleaned it, so you can do it from scratch as well. So the number is 7, R is 5. So then if you work out the combination, it is 21 as we want it to be. Okay, so that is just on permutations and combinations. Please use on your not your cell phones, on your calculators, the function NPR and NCR, and then the 1610, that if you want to use the Excel spreadsheet, you can open a new one and then just type in this, because there are already built-in formulas for permutation and combination. Okay, so let's look at another one. So in an experiment with 4 equally likely outcomes, each experimental outcome has a probability of 0.25. Okay, so you basically have 4 outcomes. They're all equal likely. So it will be 1 divided by 4, which will give you the 0.25. So again, that is, if you look at, where was that formula? So number of outcomes, total number of outcomes. So you have 1 over 4, so that will give you a probability of 0.25, which is correct. And then the last one, a subjective method of assigning probabilities is most appropriate when one cannot assume equal likely experimental outcomes, and that is also correct. Okay, so basically for this one, the one that was incorrect was with permutations. And that most likely, let's just check if we did a combination on that, if that would have, now see, so if you did a combination on option B instead of permutation, you would have gotten the 70. So also just be careful when you do permutations and combinations. They might just swap the numbers around, but you can still get the number and think you are correct. Okay, so let's again look at probabilities. Here is one about two events, A and B. They tell you what the probabilities of the two events are, and they tell you the probability of the A and B. Okay, so the first thing I will look for is this mutually exclusive? So that is not equal to 0, so it is not mutually exclusive. And so if that was equal to 0, it would have been mutually exclusive. So let's just quickly, events A and B are not mutually exclusive. Unfortunately, correct. The other one that I will then look at is independent. Okay, so for A and B to be independent, probability of A times probability of B. So let's see, probability of A 0.7, probability of B is 0.5, and if we calculate that, 0.5 times 0.7, we get 0.35, which is that number. So we know that these two are independent. And so let's just look at the answer set around independent. Events A and B are not independent. So that's the incorrect one. It is independent. Okay, so again, in the exam, if you do it this way around, you can save time. Yes, we are quickly going to do all of these, but to work this out, it does take time. Okay, so probability of A or B. So probability of A or B is the probability of A plus the probability of B minus the probability of the AND. Okay, so that is, just get my cell phone, 0.7 plus 0.5 minus 0.35. So that is equal to 0.85. That is correct. The probability of A given B. So let's just, as we nearly said at the beginning, how we read it, it's the probability of A given B. So probability, if you look at the formula, is probability A and B. So that's 0.35 divided by the probability of the second one, the probability of B, which is 0.5. So let's see, it's 0.35 divided by 0.5 is 0.7, which is correct. And then the last one that we need to look at, the probability of a complement. So complement of A is then 1 minus the probability of A. So that's the complement. So that will be 1 minus 0.7, which is 0.3. And there it is. Okay, so sometimes it's easier first to look at the things like mutual exclusivity and dependence, independence before you start calculating all the details of the probabilities. Okay, so this is a probability where they've given you nearly the numbers of the event, so or the probability of each event, and they want certain things. What they can also do is give you the table, and I think I've got, okay, and around this table, then they can ask you certain questions. So they can ask you a question here. They tell us at least the total number is 195. So they can ask you what is the probability that randomly senior managers are picked. Or they can go and say, what's the probability of a senior manager being picked if they are light smokers? So they can go into that detail. Okay, so about mutually exclusivity, and let's go, I'll quickly want to go back to nearly this slide. So mutually exclusivity basically means that there's nothing that is in event A that is also in event B. So that is nearly how mutually exclusivity works. So your AND will always be 0, where non-mutual exclusivity means that there is something that are in both. So let's, for example, say you're throwing a dice. In event A is all the odd numbers, so 1, 3, and 5. In event B is all the even numbers, 2, 4, and 6. Okay, so if I wanted to work out here what's a mutual, if it's mutually exclusive or not, you can see there's nothing that is in both of them. So here the mutual exclusivity is true. Let's look at an example where I say I take event B still stays all my positive numbers. So it will be 2, 4, and 6. But let's say event A is all the numbers smaller or equal to 3. So let's say that is event A. So event A is 1, 3, and 2. So that, and event B is 2, 4, and 6. Okay, so then there will be one of these numbers, number 2, is in both events. So then it will not be mutually exclusive because there is a number that are in 2 events. Here, when it's mutually exclusive, there are not any number that are in both samples. So that is nearly how we look at mutual exclusivity. It's, in a sense, how you can look at it as well is to say, if we look at this group of 11 people on the call, mutual exclusivity, we can say that, okay, you are in one province. You're not at this stage going to be in two provinces. So you are in Gauteng, Western Cape, KZN, Eastern Cape, or wherever, but you are in one province. You can't be in Western Cape and Gauteng at the same time. So that is, again, mutually exclusive because you can only be in one. So also something mutually exclusive is if we look at this table, you can't be a senior manager and a junior manager at the same time. You can't be light smoker and a medium smoker at the same time. But you can be a junior manager and a light smoker at the same time. Okay, so that is nearly moving from mutual exclusivity when we get probability of A and B and those things into a table. That's how you can read it from a table as well. Okay, hope that answers that one. So let's go into some of this detail. The probability that a randomly chosen staff member is a senior employee cool, and a non-smoker. Senior and a non-smoker. So they're basically asking us, what's the probability that at random you pick one of the staff members that they are a senior employee and a non-smoker. So there's only 4 of them. So that number feels way too senior employee. Sorry, not a senior manager. Sure. Senior employee and a non-smoker. Okay, very easily can make that mistake now, where you look at junior and junior, senior and senior, and not look at, so 26 divided by 195. So there's 26 of them that are senior employees and non-smoking, and there are 195 employees. So 26 divided by 195 will give us the 0.1333. Okay, so that is correct. Let's just pick another color for the next one. The probability that a random chosen staff member is a senior employee or a non-smoker. And so now we need to do it a bit longer. So what's the probability that the random chosen staff member is a senior employee or that the staff member is a non-smoker? And then we need to subtract the probability of the AND. And so that will give us the OR that we are looking for. So firstly, senior employee, we need to know how many there are of them. So it's 26 plus 10 plus 12 plus 4. So there's 52 of them. So that probability is 52 divided by 195. Then we need to know how many non-smokers there are. So that's 4 plus 4 plus 26 plus 18 plus 11. So that is the probability of the non-smokers is 63 divided by 195. Then we know We already did for and. That is for 26 divided by 195. And that will give us the total answer of the OR. So 52 divided by 195 is 0,267. Okay, so this is interesting. They already ask us in option C, what's the probability that a random chosen staff member is a senior employee? So we're actually doing that already. What's a non-smoker? So that's probably also what's the probability that a random chosen staff member is a non-smoker? Okay, so there we're also doing that. So the non-smoker is 0,323. So that is the wrong one. And then it was minus 0,133. So let's just check. 0,267 plus 0,323. 67 plus 323, that is 0,59 minus 0.133 gives us the 0,457, which is correct for B. Okay, so we know which one is incorrect, but let's then look at the last question. The events of secretaries and heavy smoking are mutually exclusive. So again, back to that previous question, mutually exclusivity is when the probability of A and B is equal to 0. Secretaries, heavy, that is 0 divided by 195, which will be 0. So you know that that is mutually exclusive. Okay, so in this one, the mutually exclusivity is sitting in the table where they basically have, so if there was one person, then it's not mutually exclusive. It will be very small. It will then be 1 divided by 195, which will be very small, but then there is one person. But here, there's 0 people that are secretaries and heavy smoking, so they are mutually exclusive because the probability of secretaries and heavy is 0. So if the probability is 0, it means it is mutually exclusive. Okay, so that is nearly a look at the probability study unit in if I ask you a bit of theory, if I ask you a bit around the definitions and if the probabilities, and then also a table. I've got one more because this one was again the same table, but the question is what's the probability that the person is a light smoker given that the person is a senior manager. Okay, so again, the shortcut to this is what's the probability of light and a senior manager divided by what's the probability of a senior manager. Okay, so that's the shortcut. So if you look at probability of light and senior manager, there's going to be 2 of them. And then if you look at what's the probability of a senior manager, so we need to just add all of them together. So it's 4 plus 2 is 6, plus 3 is 9, plus 2 is 11. So 11 over 195. That probability, we work it out, is 0,181818. So if we round it off, 0,182, which is option A. Okay, so that is just, again, looking at numbers and then getting this probability of a given. We've got it here that we also needed to look at it when it is in nearly a definition form or formula form. But if you have then the numbers, you also know now how to do that. Okay, so that is study unit 4. So let's go into then study unit 5. This one is one around, I'm going to take this one out. I'm not happy with that question. So let's go into study unit 5's work. So we get the table. It's a discrete probability. In here, there's one that is missing. So we first need to work that out, but it's also one that they ask us to work out. So let's work out what is the probability where x is 2. So that is going to be 1 minus the sum of all the others. So let's just quickly check. 0.1 plus 0.3 plus 0.2 is 0.6. So the probability of x2 is 0,4. Okay, so that is correct, but let's just put it in there, 0,4. Okay, so now you guys can see here we need to work out the mean, but I will rather first do all the ones where it's probabilities, because then I can just read it off a table. We don't need to go fully into trying to work out the mean. So I will first go and see how to work it out. So let's just use a few coloring. 2 and smaller, so goes from there up until 0. So 0.4 plus 0.3 plus 0.1. That will give us the 0.8. So that one done. Let's get another color in. So between 3 and 1. So excluding 3, excluding 1. So we're actually only looking at 2. That is 0,4. And then let's see what is the other one. Bigger than 1. Okay, bigger than 1 is not including 1. It's bigger than 1, so it's 2 and 3. So 0.4 plus 0.2 is 0.6. Okay, so then we know the incorrect one is the mean. If you wanted to work it out, you will basically need to say 0 times 0.1. That will be 0. 1 times 0.3. That will be 0.3. 2 times 0.4. That will give you, I think, 0.8. And 3 times 0.2, which will give you 0.6. And if you add all of those together, your answer will be 1.7 and not 0.7. So that is where the mistake is. Okay, but again, in most of these questions, you will nearly get to that point with the answer so that you don't need to also go into the detail to working this out. Okay, so that again you can hopefully save some time, because I know time is a big problem in the stats exams. Okay, so again, probability distribution, they tell us discrete, but also you can see 0, 1, 2, 3 with different probabilities across the line. And in this one, they're just asking us to identify which one again is the incorrect one. Okay, so let's start with x bigger than 1. X bigger than 1, it excludes 1. So 0.2 plus 0.15, that is correct. It's 0.35. X smaller than 2, sorry, let's reread that. X smaller or equal to 2, so it is 2 and smaller. So 0.25 plus 0.4 plus 0.2. We add those three together, we get 0.85. Again, very important, where I now said smaller than 2, I would have then only gone to 0 and 1, and I would have making that mistake of not adding the necessary numbers. Okay, then let's look at including 2 and including 1. And so it's basically looking at 0.4 and 0.2 because it's 1 and 2. So it is 0.6. How this could have been written as well is probability x smaller than 3, bigger than 0. Because then you would have also gotten to those two. So there are different ways of writing it. So don't get worried in the exam if now they put this down and you also get 0.6, and now you're like, oh, but why are those two exactly the same? It is because we're looking at the same two numbers. It is just written up a bit differently. Okay, and then the last one, or second last one, smaller than 1. Smaller than 1 is only looking at 0, so it is 0.25. And the last one, let's get another color. Smaller than 1 or equal and smaller, so it's looking at 1 but bigger than 0. It's only looking at 1, so that should be 0.4. That is where that one is wrong, because it is just 0.4. Okay, so again, nearly looking at the discrete, and again, I know you guys, this is all online, so you can't do this now nicely with different colors and things like that, which does make it much simpler, because then you can actually see what you're doing and things like that. But this is definitely a question that will be in your exam paper. Okay, then we go into binomial. So when we go into binomial, there's a few things that you will need. So for your binomial table, they need to give you the n, they will need to give you the pi, and they will need to give you something around the x so that you can identify it on the table. Okay, so again, important, if you want to use the table, these are the three things that you need. But also, if you want to have used the formula for this, that is also what you need to have. So binomial, they tell us n is 4. So let's look, there's n4. They tell us that your pi is 0.2, 0.2. Okay, so we basically working with that group. That now move. We're working with that group there. Okay. It was, again, it's now giving me, okay, let's just hope this will now work. Not do that weird thing again. Okay. And then they tell us that my probability that, or the x's that I need to look at is x smaller than 2. Okay, so let's get the yellow for this one. X smaller than 2. Okay, so I'm working in this area. X smaller than 2 means that I am working only with 0 and 1, not looking at 2. If it was x smaller or equal to 2, I would have included 2. But for this one, excluding 2, so I'm only looking at the 0 and the 1. The 0 and the 1 is 0,4096 plus 0,4096. So that's those two, which will give me 0,8192. And if you set, let's quickly say 0.8192 plus 0.1536. So there's the 0.1536 for x equal to 2. And if you added those three together, there is another one for you as well. So just be very careful, again, in a question like this, where just make 100% sure x smaller than 2 means you don't include 2. You're only looking at 0 and 1, because unfortunately there are more numbers for you if you need to. Um, Again, if you set x bigger than 2, you would have looked at 3 and 4, and then there was an option for you as well. So very important, nearly, that you read this correctly in what you need to do. Okay, so another one here, they give it to us in words. So you need to basically look for what you want to get out of here. So according to a report from a Center of Studying Health System changes, 20%, so that was the 20 there, delay or go without medical care because of certain concerns about cost. Suppose that you have 6 individuals, so n is 6, and the probability that more than 4, probability that more than 4. More than 4 means not 4, but 5 or 6. So more than 4 is basically looking at 5 and 6. Less than 4 would have been 3210. Equal to 4 would have just been then the 4. Okay, so probability that more than 4, 0,0015 plus the 0,0001, that will give us option 4, the 0,0016. Okay, I don't like it that they do this because there might be tables that is rounded off more. That is if you set 0 to 4. That is only if you're looking at 4. That is only if you're looking at 5. So again, a few different options for you for the binomial. Okay, and also here, just quickly that so they don't, in this question, tell us we're working with binomial. Let me quickly check. Here they set binomial, so we knew. The way here to look at it is binomial is always saying that you have two options. So it's always the yes or no, heads or tails. It's that you're always looking at. And here they said 20% of South Africans delay or go without. So it is or they delay it or they don't. So that's your two options. So if 20% delay, how many people don't delay? 80%. And so again, just that important thing, how to identify binomial is basically it's a yes or no, heads or tails. It's always the outcome is between two things. Poisson is a bit different. So, okay, here they tell us it's a Poisson, but look at, it will always have that extra thing of a time link to it. So here, a Poisson is per week. Let's quickly just Poisson. Okay, here they don't tell us anything because they already told us it's Poisson. Here again, they tell us it's Poisson. So, but the thing to look out for if I don't tell you it's Poisson is just to look at that time variable that's linked to it. Okay, so let's look at this one. They tell us it's 3.5 per week, so lambda is 3.5. What's the probability of no accidents? No accidents is 0. 0 is basically what's the probability of 0? 0,0302, which is that first one. Okay, so if they said what's the probability of less than 3, let's just, less than 3 would have been 210. It will be excluding 3. If we said more than 7, just random picking here, it will be more than 7, so from 8 and above. Okay, so again, just look at the different ways that they could ask you this one as well. Okay, so let's look at another Poisson. What happened here now? Oh, it's not doing the same, so let me just quickly do that. go into it again. Okay, so now that one is gone as well. Okay, don't know what is happening with my PC today. Okay, so question was for others at least. That one was not saved, but that was at least saved. Okay, and at least it will be on the recording. Okay, so let's check out this one. Random variable with the parameter 3.8. So there's the 3.8. And we want to know probability y smaller or equal to 5. Okay, so smaller or equal to 5, it's all of those ones. Okay, so there's not the easy way to say 1 minus. So this one is, you need to add all of those together, and you see those two are close to one another. So it's probably one of those two, but again, yeah, can't just guess which one. So unfortunately, quickly need to work out, but it's 0,0224 plus 0.085 plus 0.1615 plus 0.2046 plus 0.1944 plus 0.1477. I get 0.8156. Okay, so if you add all of them together, you will get the 0.8156. Okay, and then option or slide 22. Here we now have a bit of work that we need to do with the formula. Okay, so I've put in the formula here for you because, again, it is open book. So you are allowed to have all your study notes, all my notes with you in there. You will have this formula. So please don't learn it off by heart. So let's see the information that they give us, how we can populate this formula before we go into any of that. So they tell us, suppose that the random variable x is Poisson distributed with an expected value of 1.6. And so we know that the lambda is 1.6. So the first thing I normally look at is if this e to the power of minus 1.6 is correct for all of them. So unfortunately it is, so I can't eliminate any of them yet. Then I say calculate the probability that x is equal to 2. And so now we have this component that comes in. So now we need to go to your calculator. I don't have one, so I'm just quickly going to try to do this on Excel. So 1.6 to the power of 2. So that will give us 2,56. And 2 factorial means 2 times 1. Let me just show 3 factorial would have meant 3 times 2 times 1. So as you go higher, if it was 5, it would have been 5 times 4 times 3 times 2 times 1. So 2 factorial is that. So 2.56 divided by 2 gives us the 1,28. 1,28 e to the power of 1 minus 1,6. 1,28 e to the power of minus 1,6. There we have option B. Okay, so that is how it will look if they want you to work with a formula. It will be the same for the binomial, where they give you all of the information and you just need to basically complete the formula. And again, they will not ask you to do what's the probability that x is smaller or equal to 2, because when it's the 2, it's the 1, the 0. So something like that, they will just not have. So don't need to worry about that. Okay, so that is chapter 4 and 5. I think let's just have a break. Come back at 10. So quick coffee break, smoke break, any break that you want. And then come back at 10 and we will start just with study unit